Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why some groups just seem to nail it when solving a problem, while others just stumble around? Well, this new study dives deep into what makes collective problem solving so powerful. Imagine you have a really tough question like, how many jelly beans are in this giant jar? Some groups might just shout out guesses and average them, but other groups they might break it down. Maybe they'll estimate the size of the jar. Then how many jelly beans fit in a cubic inch and then do some math? This new research suggests that this second approach, this breaking down of problems, is the secret sauce to making groups smarter, a phenomenon they call collective Fermi estimation. They looked at over 1,000 online group discussions and found that when groups spent time breaking problems into smaller parts, they made fewer mistakes. They even did experiments to prove it. They found a way to detect this problem-breaking strategy just by reading the chat messages, and it accurately predicted how well groups would do. So, it seems like the wisdom of crowds isn't just about having lots of people, but about how those people think together. We've all heard of the wisdom of crowds, right? The idea that a large group of people, even if they're not experts, can often make better judgments than a single brilliant person. This has been seen in everything from predicting stock markets to diagnosing diseases. But the thing is, sometimes it works and sometimes it doesn't. Social interaction can sometimes make groups even smarter, but other times it can lead to people just copying each other, which isn't helpful. So, what is the difference? Previous research showed that averaging the final answers from small groups was often better than just averaging tons of independent guesses. But they weren't sure why. Was it just averaging, or were groups doing something more? This is where our researchers got curious. They realized there are two main ways groups can come to an answer. One is by sharing their initial guesses and then somehow combining those numbers, like taking an average. The other is fundamentally different. They actually reason together, breaking the problem down into smaller pieces and using approximations to build a new answer. Think of Enrico Fermi, the physicist who was amazing at making quick, rough calculations. They call this second approach collective Fermi estimation. They hypothesized that this problem decomposition strategy would lead to better results. To test this, they developed a way to measure how much groups use this Fermi approach by looking at their text conversations. Then, they ran 3 studies to see if it was true. Study 1 checked if groups that used this strategy were more accurate. Study 2 actually told some groups to use this strategy and compared them to groups told to just combine numbers. And study 3 looked at whether this strategy works better when done together in a group versus by individuals working on their own. In study 1, they got 500 people, put them into groups of 4, and asked them a bunch of estimation questions. They answered them individually first, then discussed them in a chat room to reach a group answer, and then answered them individually again. What they found, confirming previous work, was that the group S final answer was usually more accurate than the average of everyone. S initial individual guesses. This was true even when they looked at lots of different numbers of people to average. This figure shows that the black line representing group consensus estimates is generally lower in error than the blue line, which shows the error from just averaging individual guesses. And interestingly, when they looked at questions the groups discussed versus questions they didn't, the groups got much better at the discussed ones. Now, you might think that maybe the smartest person in the group just took over and made everyone else's answers better, but the researchers found that wasn't the case. Everyone in the group contributed about equally, whether they were initially more accurate or more confident. This means the accuracy boost really came from the group process itself, not just one smart person. So how did they figure out how groups were reaching their answers? They had 10 human raters read through all the chat conversations. These raters gave scores on how much each group used 2 strategies. Strategy 1 was sharing numbers, where they just shared their initial guesses and combined them. Strategy 2 was collective Fermi estimation, where they broke down the problem and reasoned it out. They found that these 2 strategies were pretty much opposites. Groups tended to do one or the other. Crucially, when groups scored higher on the Fermi strategy, they had much lower estimation error. On the flip side, the more they shared numbers, the higher the error tended to be. And again, this wasn't because the Fermi group started with more accurate individuals. The accuracy difference really showed up after the deliberation. But having humans read all those chats is a lot of work, so the researchers developed a clever way to do this automatically using computers and something called word embeddings. Basically, computers can understand how words relate to each other, like how building and floor are related. Their idea was simple. If a group is using the Fermi strategy, they'll be using words that are semantically similar to the words in the original question itself, because they're actively thinking about and discussing the components of the problem. They created a similarity index based on how related the words in the chat were to the words in the question. And guess what? This computer-generated similarity score actually predicted how accurate the group's answer would be. And it was linked to the human ratings of the Fermi strategy. It even worked better than just counting words or looking for exact matches. This is a big deal because it means we can potentially detect this smart problem-solving strategy in large-scale online discussions without needing humans to read everything. Now, all this correlation is great, but did the Fermi strategy cause the improvement? Study 2 was designed to find out. They took 240 participants, again in groups of 4, and this time they gave them specific instructions. Half the groups were told to use the Fermi method, breaking down problems and doing approximations. The other half, the numbers group, were told to share their initial estimates and combine them. And the results were clear. The groups who were instructed to use the Fermi method made significantly fewer errors than the groups who were told to just share numbers. Their chat logs also showed they were indeed using the Fermi strategy more, and talking about words more related to the questions. This study provides strong evidence that telling groups to break down problems actually makes them perform better. But then a deeper question arose: does the Fermi method only work when people do it together, or does it improve your own thinking, even if you do it by yourself? Study 3 aimed to answer that. They had participants use the Fermi method, but some did it in groups of 4, while others did it entirely alone, just writing down their reasoning. They found that when people used the Fermi method individually, their accuracy improved compared to their initial individual guesses, which was great. However, when people used the Fermi method in a group, the improvement was even bigger. There was a significant difference, showing that while the Fermi strategy is good on its own, the real magic happens when it is a collective effort. So, what is the big takeaway from all this? Across 3 studies, the evidence strongly points to collective Fermi estimation, breaking down problems and making rough calculations as a key driver of accurate group judgments. It is not just about averaging initial guesses. And that automated method to detect this strategy using word similarities is really exciting. It opens the door to studying collective intelligence on a massive scale. Just by analyzing text, this could be huge for fields like crowdsourcing, where we want to get the best possible information from large groups of people. This research really shines a light on the how of collective intelligence. It shows that deliberation, when it involves genuine reasoning and breaking down challenges, is far more beneficial than just sharing information or opinions. It is that collaborative thinking, that shared construction of knowledge, that makes groups truly wise. Of course, no study is perfect. The researchers point out that this work focused on questions with number answers. It is not yet clear if this Fermi strategy works as well for questions that have yes or no answers, or more complex choices. Also, they tested one specific reasoning strategy, and there might be other ways groups can think together to become smarter. This is where it gets really interesting for real life. Think about democracy and how we make decisions as a society. There's a big difference between just voting, which is like aggregating numbers, and really discussing and reasoning things out deliberation. This research provides strong evidence that actual deliberation, this kind of problem solving, can lead to much better outcomes. They showed that groups can be encouraged to adopt this smarter way of thinking, which has direct implications for designing meetings, online forums, and even educational settings. So, to sum it up, this research gives us a concrete mechanism for how groups get smarter, by breaking down problems. It gives us a tool to spot this happening in text, and even a way to encourage it. This is a really cool insight into how human collaboration can amplify our intelligence. Now, what's my take on this? I think it is fantastic that they not only identified this collective Fermi estimation strategy, but also found a way to detect it automatically. That is a huge step forward for studying collective intelligence at scale. The fact that they could causally show that instructing groups to use this method improves accuracy is also very powerful. The biggest strength here is the blend of rigorous experimentation with clever computational analysis, and the practical implications are massive. Imagine using this in businesses to improve team brainstorming, in education to teach better problem-solving skills, or even in civic engagement to make public discourse more productive. What could they explore next? Well, as they mentioned, testing this with different types of questions, like categorical ones, would be a great next step. Also, exploring other structured reasoning processes, not just the Fermi method, could reveal even more ways groups can become collective geniuses. What do you guys think? Have you ever been in a group that just instinctively broke down a complex problem and nailed it? Or maybe you've seen the opposite happen, where just sharing guesses led to a poor outcome. Let me know in the comments below. If you found this breakdown helpful, please give it a thumbs up, subscribe to RUBIN'S Mind Lab for more science deep dives, and hit that notification bell so you don't miss our next episode. Thanks for watching, and I'll see you next time.